The only thing we can do to make a rectangle or a trapezoid approximation better is to add more rectangles. But with that said, typically, like most of the time, except for very rare cases, a trapezoid approximation will give an answer, a result closer to the actual answer, closer to the actual area under a curve than a rectangle approximation. It turned out that the error, when we could tell the size, the direction of the error for a rectangle approximation, it had to do with whether the function the area under which curve we were finding was increasing or decreasing. It turns out that the error for a trapezoid approximation has to do with the function, whether the function is concave up or concave down. So we're going to fill in these two lines. To be very frank, I don't remember them off the top of my head. I make myself this picture every time. So I'm going to draw myself a parabola, an open up parabola, which is concave up. And I imagine trying to fit trapezoids in this parabola. And every time I do, the trapezoid, the top of the trapezoid is too tall. This area is an overestimate of the actual area. If I were to draw myself an open down parabola and try to put trapezoids on the inside, when I do that, you can see that I have this error, this space left up here. So if f of x is concave down, that's what I have here, then I didn't have, my trapezoid isn't quite tall enough to cover all of that area. This is an underestimate. And if f of x is concave up, like I had in this picture, my estimate is going to be an overestimate. So they will ask you on the AP test, if they've asked you about a trapezoid approximation and you have information about the concavity, they will expect you to be able to state whether your approximation, your trapezoidal sum, is an overestimate or an underestimate of the actual area under the curve. So one last example here. I want to use 3 trapezoids of equal width to approximate the area under y equals x cubed from x equals 0 to x equals 6. So I'm going to make myself a little sketch. The sketch isn't going to fit very much here because x cubed grows really fast. But let's say that was 6. If I'm going to have 3 trapezoids to cover from 0 to 6, each trapezoid is going to be 2 wide. So I'm going to have 0 to 2, 2 to 4, and 4 to 6. So 2 questions. Number 1, can I make a trapezoidal approximation? Number 2, is my answer going to be an overestimate or an underestimate? So my trapezoids, there's lots of ways to do this. Maybe the easiest way is to make myself a little T-chart. I'm going to need input and output values for 0, that's a 0, 2, 4, and 6. So when x is 0, x cubed is 0. When x is 2, x cubed is 8. When x is 4, x cubed is 64. And when x is 6, x cubed is 216. So I'm going to need 4 trapezoids. Each has a width of 2, right? A distance across the x-axis of 2. And so I'm going to multiply 2 by the height, the average of the 2 heights. So let's see if I can squeeze this all in here. I'm going to have 0 plus 8 is the average of the height at 0 and the height at 2. Well, 0 plus 8 over 2 is the average of that height. I'm going to multiply by 2 plus the average of 8 and 64 times 2 plus the average of 64 and 216 times 2. Whoops. That's not what I meant at all. The average of 64 and 216 is 64 plus 216 divided by 2, and I'm going to multiply by the distance across that interval is 2. When I simplify, I get 360. So this isn't, there's no context here, so I don't have units for this answer. But 360 area is the area. You can say 360 units squared. We have this second question, which is your answer an overestimate or an underestimate? Well, think about the concavity of x cubed on this interval from x equals 0 to x equals 6. So here's the picture. X cubed is concave up on this interval, so I know that my result is going to be an overestimate. I'm going to type it up. So there's my conclusion. 360 is an overestimate of the area under the curve y equals x cubed on the interval 0 to 6, because y equals x cubed is concave up on that interval. Notice that if the interval they had asked us about were, say, -2 to +6, we wouldn't be able to draw this conclusion anymore, because there would be part of the interval on which the graph were concave down, the graph of y equals x cubed, and part of the interval on which it were concave up. So we won't be able to use this statement about the error of our answer. So the direction of the error. So make sure that if you're going to make this statement, this conclusion, that you know about the concavity over the entire interval for which you're making an approximation.